Bismillahirrahmanirrahim. Assalamu alaikum. My name is Muhammad Asim. I am working as DevOps engineer. Guys, in this video, I'm going to show you how we can reduce our EKS, which is the Elastic Kubernetes Service by AWS, cost reduction. So let's begin. What we are going to do, we are going to first of all set up our a specific VPC for that Kubernetes cluster, and then we are going to set up the Karpenter, right? So in past, what I've done, if you remember, I've created a video on Carpenter about 1 year ago. So if you navigate to my channel, Cloud Geeks CA, so simply what you need to do, type the Carpenter, and you will see that, okay, might be spelling mistake, yeah, Carpenter. So you will find this video, right? It has been a while, which regarding this video. So in this video, what I'm going to do, in fact, what I have done, I've created a branch in that particular same repository in GitHub. If you see, this is the branch, and I've updated this branch. And what you need to do, simply navigate to this branch, Carpenter, and in that particular branch, we are going to use the most latest releases, and we are going to use the managed modules. So we are going to deploy first of all VPC, then EKS cluster with the managed module. This is almost the latest version, right? And once the EKS, VPC, EKS and VPC is set up, then we are going to install the Carpenter, right? So let's do that. What you need to do, you have to watch this particular video till end. So, so you will get a clear understanding how we can reduce our EKS cost through Carpenter, and I'm going to provide you the full demo regarding the application deployment and how you can deploy specific application on specific node. And we are going to provision spot instances for our infrastructure, right? So what you need to do, you need to simply clone this repo, right? And let me clone this and then switch to git clone and then switch to the branch Carpenter, right? So when you clone this repo, by default, you will land in the main branch because we are just cloning, right? So, okay, cd into this CKS. So this is the main branch. Let's check out. So these are all the branches, git branch FNA. So, but we want Carpenter. So simply, I'm going to copy this guy and so git checkout. You need to simply check out to this branch Carpenter, and you see this has been checked out. So as I discussed, other things are pretty much the basic which we are actually doing in the past, but as I discussed, we are using the latest um, modules and latest versions of the modules. So let me first of all do Terraform in it. What it does, it is going to install these modules, right? And then we are going to apply this module to make sure that our infrastructure is set up through Terraform. But regarding the Carpenter installation, we are not going to use Terraform. We are going to use, excuse me, we are going to use Helm and EKCTL utility. So let it download the stuff. And regarding the backend, definitely it's going to give me an error because you need to set up the backend. So what I'm going to do, simply I'm going to remove the stuff with regard to the backend I've set up, simply comment it to just make sure that um, I'm going to use the backend locally, right? And as this is the demo, so my state file is going to be available locally here, right? So let me do the init again and let it install the module, right? And okay, let's close this guy. And one thing I need to show you regarding the Helm. So this is the Helm shell I created. So for the Karpenter setup, we need these utilities. So you don't have to install manually. I mean, you need to simply run this particular script, and what it does, it is going to install let me fix this typo installation. It is going to install the utility like EKSCTL, right, and kubectl, Helm installation, right, AWS, that is version of CLI. And one thing I need to update you here that I've added all the official links regarding what we are doing here. So simply, if you want to learn more, you can simply navigate to those particular links and see the official documentation as well. But as this is the demo, so if you watch the video till end, you will get a clear understanding that what we are going to do. So let me first of all deploy the infrastructure, and we are going to deploy the VPC and EKS cluster, and we are going to use the latest version of EKS cluster, right? And if you navigate to this section, main TFUC, this is the cluster name which we are going to use, and this is the cluster version, right? And then what we are going to do, we are going to once everything is correctly installed, then we are going to run this particular script. You need to simply update the cluster name here and region, and that is it. So all the utilities are going to be available, right? Because by running this script, it is going to install all these particular packages which are needed. So um, as a best practice is what I can do. I usually use the container, so all this stuff is going to be available in that particular container, right? And then as per official documentation, it is going to create a service account. It is going to create a role and cloud formation template. I'm going to show you guys later. And then we are going to deploy some one sample application. So this sample application is going to be this one. But before that, once the Carpenter is successfully installed, we are going to set up the provisioner. So till the installation is going to happen, I'm going to give you a little understanding at what are going to be, I mean, as far as the understanding is concerned. So if you see, this is the provisioner and this is the AWS node template. So in this provisioner template, I've set up the limits like CPU and memory, and this is the default provisioner, right? So, and here I'm setting some of the requirement like I mean, AZ is US East 1. So my region is US East 1, and these are the availability zone 1A, 1B, 1C, right? And for the cost reduction, as this is the main purpose of this demo, we are going to use the cost effective, the most cheapest instance provided by AWS or the spot instance, and we are going to use those, right? And we are going to use T3A medium, I mean T3A instance families. You can use R5 or C5, whatever you want to use. But this is the demo, so that's why I've just added T3A, right? And I want to include this medium only as for this default provisioner. One thing regarding the default provisioner is that you can add any provisioner as you want and then use the taints. So if you have the understanding regarding the taints and toleration, taints are applied on the nodes, right? And when we deploy the pods, through Helm or YAML, we can tolerate those pod. For instance, if you apply these taints on those particular node which are going to be launched by this provisioner, pods are not able to deploy on those particular nodes because if they are not tolerated, right? So the advantage of that using taint is that you can use your specific application. It might be CPU intensive or memory intensive, or you can set up your dev or staging environment uh, in those particular cluster where you want your nodes to be, where you want your pods to be set up on those particular nodes, right? So that is why we are using those taints. So this is the taint for the default uh, provisioner. And if you see, there is a one node, AWS node template, and the name of this node template is Cloud Geek CA Provider. So this template we are going to actually provide as a reference. So uh, that is why I mentioned here in the default provisioner we are actually referencing it. So if you navigate to this app1 YAML file, which is actually a second provisioner, you can say that. But in that provisioner, actually, I'm also referencing this Cloud Geek CA provider, right? So, but you will see and the taint is going to be different, provisioner slash app, right? And if you see the taint on that, this is a different taint with the provisioner slash default. So why we are using those taints? So if you navigate to the application section in the deployment, so you see I'm going to use the basic Nginx pod, right, and install. So in that, I'm going to tolerate that. And when Karpenter is going to launch that particular node, and we have this provisioner slash app, so our pods are going to be launched on that particular node. So by demo, your understanding will be more clear how you can add multiple provisioner in your configuration file. So I've just added two default and this provisioner slash app. So that is how you can simply control where your pods are going to be launched and what sort of nodes you want. You want spot nodes, for instance. You can use on-demand nodes for production, but definitely in different environment or even in production, you can use the spot nodes as well. This will reduce your cost about 70 to 80%, right? So simply by watching this video till and you will get the 100% understanding that how you can do the cost effectiveness in your EKS setup. So this is the name of the cluster, right? You need to simply update this. So this command is regarding the list instance profile. So as we are going to use the Helm chart regarding the installation, it is going to set up the cloud formation template for us, and it is going to also set up this instance profile. So with dash, it is going to use this cluster name, right? So you need to update this in this file, right? So definitely, if you don't want other instances size, for instance, not in mean you don't want those particular sizes, but I've added in. For instance, I can use the medium and small or large, extra large. It's totally up to us. But you need to understand simply what you can do with regard to your setup. For instance, what node sizes might be you want CPU intensive application pods to launch on those particular pods. So this is the, default provisioner. So this is very basic setup we have actually set up for our default provisioner. So if I close it, for instance, let's say my application is memory intensive and I can change in this to R5, and although it has a particular taint, so the pods are going to be launched on that particular node group, right? So that is how you can control the launching of pods through through taints and tolerations, right? You need to simply understand that particular concept, but it is very easy. And for the cost effectiveness, as we are using the, you see, spot. So definitely, for instance, let's say I want one more provisioner. So simply what you need to do, copy this guy and let's say create one more provisioner, which um, let's say call app2. Might be as we discuss, my application is memory intensive, right? So then what you need to do, let's call this app2, and regarding the taints, you can call that, I mean, is going to be app2, and let's say I just want to use instead of E3 medium, I'm going to use R5. So it is just an example, right? So to get the understanding, and then you can add those annotations. So I'm going to show you that how we can set up through Helm as well, and through YAML as well. So okay, so let me simply delete this, just for this is just for understanding, right? So and then um, also have, let me show you from the UI. So if you navigate to this Terraform section, navigate to the Karpenter and app section. So I have a little readme MD as well. So just I've copied from my previous video in Nginx Ingress Controller. But what we are doing here, so I mean, we are going to simply create a Helm application, right? So what you need to do, simply navigate to this section and update the values.yaml. So if we use these values, you see, in the toleration, we are going to use this provisioner slash app equal null, and value is going to be null. So by default, if you create Helm, create and name of the that particular template, your application by default is going to be launched. So I mean, are going to be available. That particular template is going to be available. I'm going to show you that shortly, right? So let me do that. So let me take another shell. So I'm going to take one more shell here. Let me do Docker PS. Our sandbox is running. So Docker exec interactive shell into this particular sandbox, right? So I just want to show you this how create exactly what we have actually written there. So it says I'm creating it, right? So let me close all the stuff. So this is the one it has created. You see, if I just click this guy, we have the Helm. I mean, we have the values.yml. So simply what you need to do regarding the toleration, I mean, use this key, I mean, to tolerate those pods simply, which means that your pods are going to be launched on that particular node which has this key value, say. Okay, so and then simply you can use the tag and the image name. For instance, I want my particular image QuickBooks 2018 and slash blue, and the tag is gonna be latest, right? And other thing you can update here. So this is just for understanding. Everything is already there. That's why I just want to show you, and simply remove this guy, right? So this is the understanding, and our EKS node group is going to be available. So regarding that, for the very basic understanding, let me show you that what we are doing here. In the EKS, I'm going to launch two nodes with on-demand. So if you navigate to this section, EKS managed node groups, this is the sub module. I've added the link as well. So in the EKS managed node group, we are going to use min max size of 2, right? And we are going to use on demand for our, for instance, we don't want to interrupt our Karpenter parts. So that's why I added here. You can add simply multiple node groups, but definitely this is how you can do that by providing what capacity size you need. I've added some of the additional stuff. For instance, I need volume type GP3 and size of the volume, and also some of the additional stuff regarding the encryption and I mean enable monitoring EBS optimized too. So that is the basic understanding regarding this module, right? So we are going to use two on-demand nodes. So once those are launched, if you navigate to the section instances, you will see that two on-demand nodes are now initializing. Once everything is set up, what we are going to do, let me navigate to the section EKS as well from the UI. So you can see that our EKS cluster with the version 1.24 is going to be available. So simply uh, type EKS here. So click this guy and you will see that 1.24 version of EKS is available. So what we are going to do, you see, it has been deployed. So what I'm going to do, I'm going to simply import this cluster. The command is AWS EKS update. Okay, so let me remove the stuff if I already tested. So I just wanna move this guy.cube. Okay, so command is AWS EKS update cube config. Name of the cluster is going to be Cloud Geeks EKS dev, right? And the region is going to be US East 1, right? So it's going to import your cluster, right? And if I do kubectl get nodes, I'm going to show you all the stuff in the lens as well, right? So you will see that two nodes with the latest version provided by AWS as of today's date is 1.24, right? And then what I'm going to do, I'm going to simply get the contents of this context. So then I'm going to simply put this in my MNT, and MNT is mounted on my desktop. So you will see that that config is going to be available. So simply what I'm going to do, I'm going to copy this guy and I'm going to simply import this on my lens. And one thing I need to tell you that simply you need to have your access keys already available on this host machine, right? So let me open this in Lens to give us more visibility regarding what we are going to do. Then I'm going to also show you the logs as well. So navigate to this section file, add cluster, press Ctrl V, add this guy and click this guy. Okay, okay, I clicked on the wrong guy. So simply click this guy. So it is going to connect that for the, it is going to connect that uh, connect with that particular cluster which we have set up. And if I navigate to the workloads pods, navigate to the section you see, currently we don't have anything. It is just a blank fresh cluster, right? Then what we are going to do, we are going to set up our help. So you need to navigate to this section Karpenter, right? And okay, simply run the script. And just to make sure that I am on the Windows, I'm doing one thing regarding DOS to Unix conversion, and I'm going to run this particular script, right? And let me do little bit of debugging enable. So bash UX. So it is going to install all the packages, install CLI. So that's why I'm going to press close here. And this is just to show you guys. Now what I'm going to do, I've already installed all the utilities and packages. So simply what I'm going to do, and I'm going to simply, comment these lines. So let me do that. So these are the stuff I don't currently need it. I've already installed in my container. Installed my container, right? So what I want at this moment, I want to run the script. So let's do that. So the current version as of today's date is Karpenter. As I discussed, we are going to use everything latest and simply, okay, if I type Karpenter, So navigate to this section, carpenter.shell. You see, this is the latest version in today's date. We are going to use that particular version. So what it does, let me show you that the documentation link is going to be, I mean, definitely as I discussed, I've already edited all the stuff. So let me, okay, okay, yep. So let me copy this guy and simply show you guys. So you can also navigate from this section. So simply you can say that getting started with Karpenter, and you can simply type in the search bar once it's available. So, and this search bar is going to be regarding this starting with EKCTL. So I want to use EKCTL, and what it does, it is going to set up the cloud formation templates for us. So let me show you the git status. So okay, yes, and now the git status, and I just want to add one thing. Okay, no. I have updated that template, right? So if I navigate to this section, I just want to update this typo which I've done. So if I navigate to this section and this part, right? And let me do the update from the UI installation, right? And just do the commit, right? So this typo is fixed. So guys, this is the documentation we are actually following it. So simply you need to run the script, and every detail is already written here: creation of service account, creation of IAM role account. What if you want to read in detail, you simply navigate to this official documentation. I've added all the links of all which we have deployed. For instance, manage VPC, manage EKS cluster. I mean, through Terraform, everything, every link you will find in that particular branch which I've added. So everything is very much latest. As I discussed, the whole purpose of this demo is to give you guys the very latest and updated modules and setups, because a lot of updates has been done since it has been a year I created this video, and we want to I want to give you more understanding as well. So I just want to show you the other stuff with regard to the cloud formation templates, right? So if I navigate to this script, you see what it does. It is going to set up all the stuff for us, and it is creating the Carpenter service account role for that. And if I navigate to this section and simply navigate to section cloud formation, so you will see the stacks are going to be set up with this all the required stuff. So you don't have to manually, no need to install and all the stuff. You see, it has deployed this particular stack, right? And then it is going to set up all the other stuff which is required. So as I discussed, the service count, the everything is detailed. If I covered every detail here, it is going to be a very lengthy video, but I just want to show you what we are doing here is actually everything is from this documentation with detail. The steps are already there, so that's why I'm not, covering all the stuff. But what we are going to do, we are going to cover, we are actually covering the understanding how we can do the cost reduction, right? So once that particular setup, you see that particular namespace is going to be available. And this demo, what we are going to do, we are going to open the logs here, right? And see the logs of this pod as well. So, right. So what we are going to do, we are going to launch our application, and by launching our application, you will see one node or might be two nodes are going to spin up by Carpenter. Once the script is run successfully, you see it includes the Helm chart. So if I navigate to the section Helm releases, you see that one release is going to be available, which is deployed with this app version, which is the latest, right? So I need to navigate to the default section where we are going to set up our application. Then we are going to um, deploy with Helm. But first, I'm going to show you the installation uh, with YAML file. So as I already covered the theory behind that particular application, right? So navigate to the Karpenter section, and if you navigate to first of all, you need to navigate to the provisioner section. So let me apply those. kubectl apply -f, and I'm going to apply both provisioner, and you will see once those are applied successfully, it will say that it is going to be created. And um, once and then we are going to launch our nodes, right? So you need to navigate to this section, set up the provisioners, right? And then navigate to that particular section where we have our apps, cd to apps, and we are going to use this deployment.yml. So this is, as I already covered, this is the basic Nginx application. So we are going to test how we can do the cost effectiveness in our setup. So navigate to the section Karpenter app, and this is the deployment YAML. So this is my image, and you see this has the toleration provision slash app, right? So I'm going to simply apply, and it is going to use the default namespace. So let me simply apply this guy and let it apply. So once it is applied, you see this is the default namespace, right? So you see this is one pod. So um, if you navigate to this section, if I refresh it, currently no node is going to be I mean provision, because these are the on-demand instances which we have set up. Those have no toleration. So the basic stuff, for instance, the creation of this pod is happening on that particular uh, node, right? So how we can reduce our cost? For instance, let's say we want in high traffic, we want to, I mean, do the auto scaling, and our we want more instance, and we are going to use the scaling, right? Instead of previously we used the cluster autoscaler, now we are using the Karpenter, right? And beyond horizontal scaling of our pod, right? So let me scale this guy to, let's say, 40 pods in case of, it's a weekend and we have heavy sales. So our pods are going to be, you see, some of the pods are going to be in pending states because we don't have that particular, I mean, area to particular nodes. So what Carpenter does by using those provisioners, so it is going to create those particular nodes. So you see some of the pods are pending. So you see it has launched that particular template. And if I scroll a little bit here, you see the provisioner is app. It is not using the default template. So as I discussed, if I simply refresh it, what it does, it is going to launch that particular provisioner with the slash app. As I discussed in the start of the video, if you are watching my video from start, we want that particular provisioner. For instance, we are using app, and it is going to use that particular size, and you will see that it is going to use the spot. So let me show you. See, the life cycle is spot. So that is how our pod which are going to be is in pending state are going to be, you see all pods are running. So if you navigate to the deployment section, you see all the pods are running. That is how we can save our costs, and it is going to be cost reduction from 70 to 80%. You can use these. And Carpenter is so smart. I mean, let's say all of our application is deployed, and automatic auto scaling is going to be happening, right? And I'm not going to cover all that, but let's say simply reduce that particular port scale to only one. And this process is actually happen automatically once the CPU, yeah, memory utilization is going to be reduced. But you see, if you navigate to this section, you see all the pods are gone now. So what effect Carpenter has? What Carpenter will see will automatically detect that we don't want much capacity. So what it does, it is going to automatically reduce the size. And if you navigate to the section, let me navigate to the Carpenter. Let me close this up, provisioner. So default, right? And if I navigate to the app, so you see TTL seconds after empty. After 60 seconds, it is going to remove those nodes, and until expired is after 7 days, it is going to simply remove those particular nodes. So if I navigate to this section, you see TTL is now applied and it is of 60 seconds. Once that particular 60-second TTL is going to be done, what it does, it is going to simply delete that particular node. So we have to wait for a while till 60 seconds. So let me navigate to this section and try to refresh it. You see one of the node is already gone and logs are going to be shortly available that it is going to delete that particular node. You see coordinate node, and then it has deleted those node. If I simply refresh it, you will see shortly that other nodes are going to be also destroyed. And one node is already there. So it's, let me close this guy, and you see shutting down is in progress. So this is how, guys, we can do the cost effectiveness over of workload on EKS service, right? EKS clusters. So let me do running, and now I'm going to simply delete that particular guy. kubectl cube. Okay, let me simply do delete. Instead of running the whole command, I'm going to simply delete this deployment, and you see that deployment has gone, no deployment available. Now what we are going to do, we are going to, let's say we are going to use the YAML, right? And through the Helm chart. So okay, these logs are, guys, coming from this Carpenter, right? So simply if you want to see the logs again, let me show you that you can simply open these logs and you can see the logs here. So let's try to create a very fresh application. And although I've added that particular application as well, but let me show you how you can do the testing of that particular application. So let me simply navigate to this section, MNT, right? So again, I'm going to create Helm, create hello, right? So it is going to create that particular chart for us. So let me show you, this is mounted here, so that's why I just want to show you. So let me close the stuff here which you don't want, right? So navigate to the section Carpenter, right? And navigate to the section app, right? So what we are going to do, simply I'm going to update the particular chart. So this is the fresh chart, right? So I need to add the toleration. So instead of that particular provisioner, let's say, let me open, I want the default provisioner, right? So simply click this guy, and the default provisioner key is this one, right? So let's try to use that. So what I'm going to do, okay, navigate to this section. I'm going to simply copy the values. So make sure that there is no indentation issue. So I'm going to copy that, but I want to simply use the default provisioner instead of app, right? And auto scaling you can enable, and I just want to update my app. I mean image. So this is my image. Previously we used the different image, and I'm going to simply update this image to blue. And previously used the green image, and let's say I want to use the different application, and just for understanding, and we are going to use this. So the command which we are going to use, simply you need to copy this command and navigate back, and this is the command. So if you want to do the dry run and all the stuff, so but I want to install my application, so simply it is going to create the namespace app instead of using the default namespace. So let's try to test if everything goes well. It is going to do the installation of that particular app, and let's see. So it should create the namespace app, and our application is going to be, once available, it is going to simply um, update this area regarding that successful application. So if I navigate to this section, you see one namespace has been created, and releases chart. So pending install. So what it is currently doing right now, it is going to do the pull. So I just wanna show. I have to wait for a while. Uh, okay, seems like okay. There is typo here, guys. So quick QUIC QuickBooks 2018 slash blue. That's why it's unable to launch it, right? So QuickBooks 2018 blue, and the tag is latest, right? And instead of running it again and again, and let me try to simply remove this release. You can use the helm uninstall and delete command as well, but I just want to use this UI for quick setup. So to let me run this particular command again, and because there was a typo in that particular image, so it's a very tiny image, so should be running. So you see, it has been deployed in that particular namespace. And if I navigate to the release section, you see it has been deployed. And let's navigate to the deployment section. And I just wanna scale this particular guy to, let's say, these many pods. So guys, these are the logs which we have already opened with regard to the Karpenter. So let's see what happened. So you see, it has created the launch template, and it has launched the instances. But you see, this temp provision is default. So if I navigate to this section in the UI, now you will get a better understanding. You see, this time the provision is default. That is how you can add multiple provisioners, and this is going to be definitely the spot. When I navigate to this section, you see this is the spot lifecycle. That is how you can reduce size, and you can add instances or control what sort of GPU memory or CPU you want for your applications. And if you don't mention it, definitely Carpenter will automatically decide the right size of instance and machines for you as well. But I did little more stuff. So if you want to control, and if you want your specific application deployed on specific machines, that is how you control it. That is it, guys. If you like the video, please like, share, and subscribe the channel. And see you in the next video. Thank you. Have a nice day.